All right, so we started the recording for today's AS class. We're continuing the discussion for the paper two electricity solution, and this is question number 8B for the Karshos application. So my students have been able to solve this thing up to B2. So we're gonna try to attempt B3. Let's have a look. Question number B3 says between E1, E2 are I1 and I2 in the loop A, B, C, X, Y, Z, A. So this is the entire sequence of the whole loop. So we start from point A and we'll go from A through B, C, X, Y, Z, A. This is the entire sequence that we need to follow. So all of this outer circuit is something that we need to work with. So let's start from one point and slowly go around the circuit to figure out this whole problem. So have a look. Here we have point A, and this is our resistor I. So first we're going to write the potential drops. So if the circuit current direction is same as our loop direction, it will be a positive potential drop and vice versa. So I'm going to write I1R. Then B2C, we don't have anything, forget about it. C2X, we have I2 current going in the opposite direction with resistor R. So minus I2R. Then from X to Y, we don't have anything. From X to Z, apparently there is no current. Now you have to understand, X to Z doesn't have any level current, but this X, Y, Z, A, B, this is a single branch. This is a single branch. Being a single branch means that every part of this branch will have the exact same current. One of this current was labeled over here, which means at this location also we are going to have I1. This I1 current is flowing through this R resistor. So this is going to be plus I1R. And then if we go from Z to A, we don't have anything. So these are all the potential drops that we have. So as you can see that we have two I1 into R. We have over here, one is over here, one is over here. So we can effectively write them as two as a single part on the next part. Or if you want to just keep it this way, this is also good. Equals to, now we have to look at the EMF sources. Within this loop of A, B, C, X, Y, Z, A, we have two EMF sources. E1 is here and E2 is here. You need to have a look that E1, because of its polarity, which is the positive and is the negative end, this will try to produce a current in this orientation. This will be the natural tendency for the current direction for the source E1, which happens to be the same direction as our considered loop. So E1 should be written as a positive EMF source, whereas E2 will try to produce a current in the opposite sequence of our considered loop direction. So E1 has a positive end over here, negative end over here. This is the opposite loop direction. So that's why this one is coming as a negative EMF. So minus E2. That's the entire equation.
X to Z I1 কেন হবে আবার বলবেন?
Uh, because this whole part is one single branch. Within a single branch, you can only have one value of current because no part of the wire will or battery will actually store charge. The amount of current, amount of charge per second that flows through any segment will be the same for the whole segment. Or in other words, I can say that every single part of this whole branch is in series with each other. If you want to even consider the whole this whole branch as different part, let's say this part, this part, this part, this part, all of these parts are in series with each other. They're one after another, which means they have to have same current.
বুঝতে পেরেছি।
আচ্ছা, এরপরে আমরা এরপরের কোশ্চেনটা একটু ট্রাই করি। লেটস ট্রাই দ্য নেক্সট ওয়ান, which is question number 9. আচ্ছা, question number 8 এর ফার্স্ট পার্টটা কি আমরা বুঝতে পারছিলাম সবাই? This one I would like to discuss this one in detail because there is some interesting part, take things to take into consideration. So let's see. This is a register combination that we have. Now we have open-end register combination over here. So we have 6 node points labeled over here, A, B, C, X, Y, Z. Now, this is the interesting problem which we haven't come across earlier in our O levels. Calculate the total resistance in terms of R between points A and C. This essentially means that if we connect an ohm meter, one end over here and one end over here, and this is an ohm meter, so how much should be the resistance that this ohm meter is going to measure? Now, a couple of things you need to consider that you have to judge that whenever this ohmmeter will work, if let's say if current starts flow through one of these path, one of this node point, how this current is going to flow till it comes out of the other end. Have a look. The current is going to flow through the R resistance, obviously. Then it's going to come to junction B. Now you can see that from junction B to junction C, we have a single piece of wire, whereas we have another alternative path through two different wires over here. So this is a resistance path, probable path, and this is a zero resistance path. We do know from our O levels that whenever there is a zero resistance path, that will basically take all the current, and within the resistance path there will be no current at all whatsoever. So even though there is a possible path, no current will flow through this pathway. All the current will simply gonna flow through this path. So you have to judge how the current is gonna flow. This is a very minor thing. So for this question, for this sequence, the resistance over here should be only R. They have given you a whole space over here to work, but honestly speaking, for most part, you don't need that space because you can see that all of these questions have only 1 mark each. So feeling compelled or moved to do some compulsory calculation over here is something that you should not get to be trapped with. Be careful about that. That's for the first one. So then for the second one, they are saying that what would be the total resistance between B and X, which means that if we now connect our resistor through these 2 points, ohmmeter, if you connect an ohmmeter across these 2 points, what will the total resistance? Once again, have a look. If some current starts to enter this loop from this point, comes to the junction B, there is no way the current can come out of A point, because in this case, there is nothing to go out of A. You have to understand that whenever we are considering Vx, this earlier ohmmeter doesn't exist. So this circuit has to be considered invalid for the number 2 option. So after reaching to this point, current can go in 2 different ways, this way and this way. In this pathway, the current is going to flow through this resistor R and eventually flow through XY, and eventually through the Y point can come out. Here it can flow through BC and flow through R and eventually come out over here. So you can see that there is practically 2 parallel branches. One is this one, the other one is this one. Considering the current flow path, there are 2 parallel branches. Parallel branches essentially means this resistor will be R by 2. If you don't want to write it in this format, you can simply write 0.5 R. That also works. Then comes the last question between A and Z. So that is actually not so difficult. You can see that if we have two anometer connected across A and Z, so these are A point, these are Z point, we can have to simply judge that if current flows in through, current is going to split into 2 parts, and so there are basically 3 parts in series. This resistor itself, this parallel combination by its own, and then this resistor. So you can simply write R plus R by 2 plus R. So ultimately you get 2.5 R. So that's what you're going to write. No calculations is necessary for you to show over here, because basically we have everything in a very easy to work with problem. All of the are identical resistors, so we don't have to bother about that. বুঝা গেছে কি এই পার্টটা, যে ডিফারেন্ট ডিফারেন্ট জাংশন পয়েন্টের জন্য আমাদের কনসিডারেশন গুলো কিভাবে করতে হবে? ক্লিয়ারলি বুঝা গেছে এভরিওয়ান?
জি স্যার।
আচ্ছা, এটা গেল। এরপর আমরা আরেকটা জিনিস দেখি। Question number 9 is also pretty much the same thing. Here you have a bit of recipe calculation, and then you have another one of the Kirchhoff's law. I want you guys to try this one. 9b to try করো সবাই। I'm going to zoom in the circuit. This is which page? 13, 14. No, you can have it on either side of the page of the same fold. So try number 13. Sorry, number 9b. Number 9b এর জন্য ইকুয়েশন গুলো লেখার চেষ্টা করো. I'll help you. Give it a shot, everyone, right now. So we resume the recording because we are now attempting to solve this one. 282. Okay, we're gonna try to solve this for the loops. So let's take it out. This much will be good. So have a look. Question says the two cells of EMF1 and E2 are connected to resistors R1, R2, and R3 as shown in figure 7.1. We have all the individual possible current directions for the individual branches are given. So you have to understand first thing first that if I1 is flowing through here, I1 is also coming out through here. If I2 is flowing through here, I2 is also flowing through here. If I2 is flowing by this way, I2 is also coming out from here. I am just writing these values because I want you to have a visualization for how this works. One branch, one single branch or one single pathway of current flow will always have same current in every part of it, which is really important for you to understand. Now here it says that write down the expression for using I want to এটা তোমার সবাই পারছো এটা নিয়ে আমার কিছু বলতেছে না তো বলছে use Cauchy's second law to write down a relationship between IE1 R1 R2 I1 and I3 for the loop A B E F A. Let's find that out. A B E F A. So this is the top loop that we're trying to go for. Let's start from A থেকে R পর্যন্ত B পর্যন্ত আমাদের একটা রেজিস্টার আছে এই রেজিস্টার থ্রু দ্য কারেন্ট হবে হচ্ছে I1, so we can simply write the potential drop would be I1 R1. This potential drop should be I1 R1, and then from B through E we have I3 R2, so plus I3 R2. We are giving plus because our consideration is this way, and the current is also for the assumed current direction is also in the exact same way, so that's why we are giving the same positive sign as potential drop. From E to F we don't have anything. From F to A we also don't have anything. So basically this is the whole point of the potential drop. Should be equals to, let's look for a potential, or let's look for an EMF source. Over here we have one EMF source which is E1, and E1 by its polarity, positive and negative, if we only consider this part of the circuit to be existent, forget about this part for the timing. So this would be the preferred direction of current flow that E1 will try, and we are considering our loop also in this same direction, A B E F A. That's why this output EMF should be positive. এটা বুঝা গেছে সৌমিক?
জি স্যার, এটা বুঝেছি।
আচ্ছা, পরটা দেখি A B C D E F A. So we are now skipping the mid branch. We are going for this whole entire loop. So we have to consider the branch currents. Once again, A to B we have the potential drop I1 R1, and then B to C we don't have anything, so if you can forget about that. From C to D we don't have any resistor, forget about that. From D to E we have some current and we have some resistor. Now what we have to look for is that I2 and R3, I2 is the current that is coming out of R3. They intentionally messed up this current and the resistor. You can see that here is R2 and here is I3. Here is R3 and here is I2. They intentionally messed it up so that the students can feel a bit of trouble maybe. Did I mess it up as well? Why did I write I3 R3 here? I messed it up as well. I fell for that trap. This was wrong. Hold on, এই ভুলটা খেয়াল করছো? This is not supposed to be R3. I just on hype wrote it as I3. I assume that I3 is the current through R3, but that's not the case. What should this one be? This number should be what?
R2.
This one number is supposed to be R2. So that's the trap which I fell for. Successful CA people. Sorry. So I1 R1. Then from B to C we don't have anything. C to D we don't have anything. D to E we have minus I2 R3. From E to B we have, sorry, we don't have, we're not going to go B2, so we're going to go E to F, nothing. F to A, nothing as well. So this is the only two resistors, so only two potential drops, equals to, once again, now we have a loop that this was our considered loop direction. Which cell will try to produce the current in this direction, and which cell will try to produce the current in the opposite direction for the natural polarity. So this is the positive end, this is a negative end. So E1 will necessarily try to produce a current this way. Normally it will attempt to. So E1 goes on as a positive EMF source, whereas E2 will essentially try to produce a reverse current because E2 has positive end over here and negative end over here. So E2 will try to produce a current in the opposite direction of our considered sequence. Considered sequence মানে হচ্ছে A B C D EFA, এটা হচ্ছে কনসিডার সিকোয়েন্স। আর কারেন্ট ডিরেকশনটা ডিপেন্ড করবে হচ্ছে তাদের পোলারিটির উপর, যে এটা কোন দিকে পজিটিভ কোন দিকে নেগেটিভ। Since E2's polarity is reverse compared to our considered loop direction, this one should come on as E1 minus E2. বুঝা গেছে?
জি স্যার।
Good. আচ্ছা, আমি নাম্বার 5টা বুঝে দিয়েছিলাম, নাম্বার 5টাতে আমি ব্যাক করতেছি, নাম্বার 5টা আমি ডিটেইলসে বুঝাবো, এখানে খুব ইন্টারেস্টিং কিছু জিনিসপত্র আছে। নাম্বার 5টা মানে আস্তে 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 বলছিলাম, রাইট? নাম্বার 5 বুঝাইছিলাম আস্তে আস্তে, মাই
জি
ব্যাড।
স্যার।
আমি বুঝাতে চাবো হচ্ছে এখন এইটা। এটা একটা ভালো কোশ্চেন। নাম্বার 7, নাম্বার 7, আচ্ছা তোমরা একটু ট্রাই করো আগে, নাম্বার 7 একটু ট্রাই করো। এই টেবিলটা ফিল আপ করা মোটামুটি, এখানে 5 পোলাপান সবাই 3 পায়। গেটিং 3 in this table is pretty easy, but getting 5 is not so easy. But give it a try. I want you guys to give it a try. Number 7 টা ট্রাই করো, আমি রেকর্ডিং পজ করতেছি। So এই কোশ্চেনটা actually, to be honest, in my opinion, quite an interesting question, because there are a lot of stuffs to understand for in this question, especially the pathway for multiple branches of current. আমি ওই জিনিসটা নিয়েই কথা বলবো মেইনলি। না, ওকে কষ্ট দিতেছি না তো, নেভার মাইন্ড। ওকে, দেখো কি করতেছি আমি। The question says each heating element is rated as 1.5 kilowatt, 240 volt, and may be assumed to have constant resistance. The circuit is connected to a 240 volt supply. Calculate the resistance of one heating element. You have to understand this information first very carefully. This information means if these resistor elements are connected to a 240 volt supply, in that case, and that case only, their power would be 1.5 kilowatt. If you reduce the voltage supply, their power would not be as much. It would be less. So first of all, they're asking us to calculate the resistance of the heating element. This is pretty simple. P equals to V squared by R. You place all the values, you get the resistance, and done. Then comes this interesting question. The switches S1, S2, and S3 may be either open or closed. Complete figure assessment to show the total power distribution of the heater for the switches in the positions indicated. Let's have a look. The first position says open, close, close. So if S1 is open, no matter what happens within this circuit, the output power of the total power distribution of the heater would be 0. So you get this one mark. Then it says closed, closed, open. So S1 is closed. I'm gonna draw this over here, and maybe later I'll erase this. S1 is closed, S2 is open, and S3 is closed. And let's now try to judge the possible path of current. Am I wrong? S closed, closed, open. Sorry, Bhul leksi. Closed, closed, and open. Now have a look. If you just try to judge that current starts its journey from this point, just assuming current is going to come up here, current cannot go through this pathway because this pathway is practically blocked. Current will have to pass through the heating element A. It will reach up here, and once it reaches here, it will not go through B because there's a resistance pathway, where in alternative to resistance pathway we have a closed switch pathway, short circuit like this. So all the current is going to bypass this resistor and eventually flow through the closed switch and eventually reach up over here, which means ultimately here A resistor is receiving all the 240 volt. So essentially its power would be as rated power 1.5 kilowatt. We are good. We don't have to write the unit is already given. And then it says closed, closed, closed. Now have a look. If we now okay, if we now consider this one is closed, this one is closed, and this one is also closed. So what is going to happen? Current is going to come out here, come in here. Then let's see if the current can get into two branches. Yes, the current can go into two branches. Well, this branch is open. Sorry, this branch is open means this branch is available. The current can drop in through here and eventually flow out to back to the source through this pathway. So this is one of the pathway of the current. And if you just observe for this branch, you can see that for this combination type, C has direct connection to the supply. One is over here and one is all the way through here, all the way up over here, which means C will also get full 240 volt supply. Which means C will also get full 240 volt supply and has a power of 1.5 kilowatt. So, and so this is the combination for C. Whereas for A, we pretty much have the earlier situation, pretty much exactly the earlier situation where where the current after coming to this point, current is going to get split through A and eventually flow through this pathway and bypass the resistor component B and flow through this switch and eventually go up here, here, and back over here, which means both of these resistor components will get full 240 volt supply and have their full power of 1.5 kilowatt being in parallel, that is. As a result, the total power output of this